We have this white powder in front of me. You've got a big smile on your face.
I do, because I don't care who you are, you should definitely be having this. So let's talk about creatine. Phenomenal research shows you can creatine your way out of sleep deprivation. It can protect your brain against a concussion, stroke, from stress. And there was a study done on Alzheimer's disease patients, and they found that patients not only preserved their cognitive functions, but they had more energy and they were able to exercise more. And I know this because I'm a clinician, and over the last decade, I've been surrounded by the greatest neurosurgeons in the world studying the brain. And so I'm here to tackle one disease, and that is Alzheimer's, because it generally starts in our 30s, and 60 million people worldwide have Alzheimer's, 70% being women. And I get angry and I get passionate because women have been lied to, they've been underrepresented, they downplay their symptoms, or they're too scared to ask their doctor for advice. And what people don't really know is that it is a preventable disease, but it's like end-stage cancer. Once you get the diagnosis, there is no cure. And the fact that so many people are at the mercy of a disease that is preventable is not okay with me. And I don't think people understand these things. Like, people don't really know that we're becoming more sedentary, which is a disease. And there was a study that was done on this that showed that if you do 10 air squats every hour, this can compensate for your sedentary lifestyle. And then we have several lifestyle factors that can lower your risk of getting Alzheimer's disease, as well as showing you what 5 minutes a day can do for your brain performance, just using a tennis ball and an eye patch.
Guys, I've got a favour to ask before this episode begins. 69% of you that listen to the show frequently haven't yet hit the follow button. And that follow button is very smart because it means you won't miss the best episodes. The algorithm, if you follow a show, will deliver you the best episodes from that show very prominently in your feed. So when we have our best episodes on this show, the most shared episodes, the most rated episodes, I would love you to know. And the simple way for you to know that is to hit that follow button. But also the fact that I think 41% of you have chosen to follow the show, that listen to it regularly, is the reason why we've been able to improve everything. It's the simple, easy, free thing that you can do to help us make this show better. And I would be hugely grateful if you could take a minute on the app you're listening to this on right now and hit that follow button. Thank you so, so, so much. Louisa, what is it you do in simple terms? And I guess most importantly, why is it that you do it, and why now?
Over the last decade, I've been studying the brain. I'm both a clinician and an academic, so I get to see the brain and I also get to research it. And I'm really here to tackle one disease, and that is Alzheimer's disease.
Why is this so important now?
Right now, because 60 million people worldwide have Alzheimer's disease. That number is going to triple by the year 2050. 110 million women will have Alzheimer's disease by the year 2050. This is a disease that robs you of who you are, your complete identity. So we're going to get really into this straight away because I brought Henry with me. Right?
And for anyone that can't see, Henry is a model brain that she's holding in her hands.
This is around 2 pounds. And if you actually feel it, and, if you actually feel a real human brain, it feels like tofu. But this is everything you are. And the fact that so many people are at the mercy of a disease that is preventable is not okay with me. It doesn't sit well with me. We used to think that women were disproportionately affected by Alzheimer's disease because we lived longer, because age played a role in it. But we now have substantial evidence to show that it's not the fact that women live longer or people in general, because dementia and Alzheimer's disease are not part of the natural brain aging process. For women, and they differ from men, and we can separate the sexes and talk about it. For women, it is purely because being a woman is a risk factor for getting this disease. Now, if we go through and we have a look at all of the people that currently have Alzheimer's disease, 95% of them could have been prevented, because this is not a disease of genetics, it's a disease of lifestyle.
95% of it could have been prevented.
Correct. We're born with our genetic makeup, meaning that, for example, if you have a genetic mutation on chromosome 4, you will get Huntington's disease. There is nothing we can do about that. That's how you were born. But when it comes to Alzheimer's disease, there's around 20 to 30 genes involved in the disease. only around 3% of the disease cases right now were driven through those genetic mutations. The genetic mutations that you are born with, you get them from mum and dad, are presenilin 1, presenilin 2, and the amyloid precursor protein. So if you have a genetic mutation in one of these genes, you will get some form of dementia.
What is the age range where people will start to experience Alzheimer's?
Let's just actually take a broad overview of what Alzheimer's disease is, okay? So you've probably heard of dementia.
Yeah.
So dementia is the umbrella term. So Alzheimer's disease sits under the umbrella. It's a form of dementia. There's frontotemporal dementia, which is what Bruce Willis has. There's dementia with Lewy bodies. There's Parkinson's dementia. There's vascular dementia. This disease, dementia or Alzheimer's disease, is a disease of midlife. And so it generally starts in our 30s. It starts in our 30s, but the first symptoms show up in our late 60s, 70s, and beyond.
When you say it starts?
Yeah. Our brain fully develops at around 25 years old, 25 to 30. And after that, that's when if we don't take care of our brain, we start getting a decline in these functions. Now, let's go back to the brain. The brain is 87 billion neurons, around 5 to 10,000 connections per neuron. My favorite area of the brain is the cerebellum, and the Purkinje cells inside the cerebellum have upwards of 50,000 connections per cell. So tightly dense, and there is so much happening. It takes 20% of the total calories that you consume every day to power this thing. And it's the most vascular rich organ in the entire body. Over time, through things such as sleep deprivation, poor diet, lack of physical activity, environmental toxins, this slowly erodes at the functioning of the brain. And over time, this starts to compound, because that's what biology is. Everything is compounding. One night of sleep deprivation raises your risk of amyloid beta, which is one of the hallmarks of Alzheimer's disease pathology, by 4%. That's just one night of sleep deprivation. Imagine a new mother or a shift worker or a physician in their residency getting countless nights of sleep deprivation day in and day out. Imagine all of that compounding. And what happens? Well, we end up with either neuronal loss, which is like the complete atrophy of certain parts of the brain. And that's what is mild cognitive impairment. Mild cognitive impairment is a pre-dementia state.
So what is this that I have here, this photo of a brain?
You've got the sagittal view right now of the brain, and we're looking at a healthy brain on here. As you can see, I'm going to show it up here. On the left-hand side, you can see that the brain is thick. We can see that the integrity of the gray matter, which sits out here, is thick. It's voluminous. Okay. We can see that the ventricles are smaller. We go over here and we see thinning of the cortex. You can see these big spaces between the gyri. These are thick because the gray matter has atrophied. It's shrunk. You can see that the space between the cortex itself and the skull, there's a bigger space. You can see these ventricles here, these butterfly-shaped ventricles. This is thicker. This is thinner. We can see atrophy down here. So essentially, the brain is getting smaller and smaller.
At the age of 30, if I do everything right, and we were to sort of plot this on a graph of where I land at 70, what is the variance of where I'll end up at 70? You know, my brain is quite important to me. And I do worry. I think, I think I worry in part because I sit and interview a lot of people at a lot of different ages. And one thing you notice as an interviewer is some people at 60 are razor sharp. Mm-hmm. And some people at 60 are not as razor sharp.
Yeah.
Their ability to articulate their words, their memory recall, their ability to understand stats and stories, all of this. And I sit here and go, I wonder what the difference is.
Yeah. And that's actually beautiful because it brings up this important concept in neuroscience called cognitive reserve. And that's your brain's ability to withhold capacity to overcome stresses. Okay. So you've probably heard, for example, let's use the analogy of physical performance. Mm-hmm. Your VO2 max, which is a measure of your peak respiratory fitness, you know, how well you can utilize oxygen mm-hmm. when you are at a high intensity state. How well does your body utilize oxygen? The fitter you are, the more reserve you have to overcome stress. Stress such as an infection, everyday stresses, sleep deprivation, surgery. The more reserve you have in your bank to overcome that. The same is with your brain. The more cognitive reserve that you have, the more cognitive capacity that you have been training year on and year out will save you at 60 from harmful insults, such as you can get a woman at the age of 80 with a head full of amyloid beta.
Amyloid beta being?
One of the hallmarks of Alzheimer's disease. You can get somebody with a head full of amyloid.
Which is like a plaque on the brain.
Yeah, it's a protein that's actually, it's a protein that lives inside the neuron itself. And we can explain what that is, which I will in a second. But let me just tell you, you can have a head full of amyloid in this person and they have retained their cognitive functions. Then you can have somebody else with hardly any amyloid, but they've lost their cognitive functions. And this all comes down to cognitive reserve.
And cognitive reserve lives where in the head?
You've got around 5 to 10,000 connections per cell. Over time, those connections fail. Now, those connections are responsible for your thinking, your processing speed. Every time you have a thought, you build a new connection. The more connections that you have, the more things that you see, the more novelty that you give your brain, the richer it gets, the more stable it gets. So the ends of the neurons, we have dendrites. And coming off the dendrites are these little trees. Imagine a branch. That's the dendrite, and all of the leaves that come off it, all these little dendritic trees, if you will, and they connect to nearby cells, 10,000 cells. Over time, those are the connections that fall. Those are the connections that fail. They fail because you don't utilize them.
So the way that one would build reserve at the age of 30 is
by exercising. We can build reserve in a number of different ways. In fact, there was a really wonderful study that just came out that I just read about, and they found that those who preserved cognitive capacity at 75 years old were handwriting and reading. So handwriting and reading preserves cognitive functions. Exercise is one of the most potent stimulus for brain health and Alzheimer's disease prevention and cognitive reserve. The more you exercise, the bigger your brain.
What about scrolling on social media? Does it improve my reserve if I'm watching videos?
It's in the opposite.
Why would that be? Because I'm still learning stuff.
Yeah.
When I'm on the internet.
Because what you're doing then is you are relying on short dopamine hits. Every time you scroll, you're sending signals to your brain that you're getting a dopamine hit. And your brain gets used to it. Remember, your brain is only there for two things: survival and reproduction. So every time that you stress your brain in the smallest amount of times, you're giving it dopamine hits, it doesn't allow us to do other things for a sustained period of time, like focus, read, have a conversation.
So writing and reading are good for building up my neurological reserves.
Yeah, neurological reserves. It doesn't compare to what exercise can do for the brain. And it's so sad because around 80% of the US population don't exercise for at least 30 minutes a week, which is actually quite scary. The physical activity guidelines are 150 minutes to 300 minutes of moderate to rigorous physical activity per week.
What's the most compelling study you've ever encountered that proves that exercise is central to Alzheimer's prevention and brain health?
When we look at all of the data, we can see that the biggest amount of return on investment is from resistance training.
Resistance training being?
Strength training. One of the most compelling studies was probably the SMART trial, where they took a group of people with mild cognitive impairment and gave them 2 to 3 times per week of resistance training. And they not only preserved their cognitive functions, they enhanced their processing speed, they enhanced their fluid intelligence, and they had slowing of the grey matter.
The grey matter?
Yeah. So your brain consists of both grey and white matter. So grey matter are the cell bodies that lives on the outer portions of your brain. And the white matter is deep within the brain. And that's where all of our myelinated neurons live. And over time, we see that we can have little lesions in the white matter of the brain. So a lot of the times people will ask me, Stephen, I'm scared my mother had Alzheimer's disease. I'm scared I'm going to get it. And we were talking about genetics before. And there's another genetic risk factor that we didn't talk about. The ApoE4 gene is one of the strongest risk factors of getting Alzheimer's disease, but it is not a foregone conclusion that you're going to get it. So Chris Hemsworth was tested and he has 2 copies of this gene. So you get 2 copies, one from mum, one from dad. It's the apolipoprotein E gene. And it comes in 3 main variants. So you've got ApoE2, ApoE3, and ApoE4. So I'm a 3-3 carrier. I've been tested. And that's the general population. They're 3-3. So it doesn't raise my risk of getting the disease, but it also doesn't protect me. If you've got a copy of the ApoE2 gene, it protects you against the disease. But when you have a copy of the ApoE4 gene, it raises your risk by 2 to 3 times. If you have 2 copies of the gene, it raises your risk by 10 times if you are a male. Here's the devastating thing. If you are a female with 1 copy of the gene, you are at doubled the risk than your male counterpart. So 1 copy of the gene, of ApoE4 gene for a female, raises your risk by about 6-fold, whereas 2 copies raises your risk by 15-fold.
And how would one go and get checked?
You can get the ApoE4 gene checked out with your doctor. It's a simple blood test.
On this point of resistance training, I've heard you talk about how the legs are so important. Yeah. Having strong legs.
Having strong legs is by far the most important tool in your toolbox for the prevention of Alzheimer's disease. And this was made certain to me when I read a study done on identical twins, exact same genetic profile. And they tracked them and they did cognitive tests and MRIs. And they tracked them over a 10-year period. And what they found was that the twin who possessed the greatest strength and the most leg power had a bigger brain, larger gray matter volume. They preserved their cognitive functions. They did better on different cognitive tests.
Why is resistance training increasing the size of my brain?
Resistance training does so much for your brain. The first thing is we have to think about the journey that we're going on, right? So when you look at all of the studies, I want to make it really clear, all of the studies show that in order to produce the neural effects of resistance training, you need to be lifting at around 80% of your 1 repetition max. So 80% of 1 RM. So that's quite heavy. There is so much controversy on social media right now. Should I lift heavy? Should I lift light? And when it comes to hypertrophy alone, so increase in muscle mass, muscle cell size, you can get there. Men can get there. Women can get there by lifting light, high reps, or you can get there by lifting heavy and low reps. It just depends on who you are and how much time you have. But when it comes to the brain specifically, you want to be lifting heavy for several reasons. The first one is when we lift heavy, when we literally, when we contract our muscle like this, we are releasing a whole set of chemicals. They're called myokines. And when they're released from the muscle, they go up to the brain and they do beneficial things for our cognitive performance, our cognition, and they help with the growth and proliferation of new neurons in the hippocampus. And it's the first thing to go during Alzheimer's disease. It actually shrinks. This holds our memory. This is where a lot of our memory consolidation and learning takes place, which is why short-term memory is the first thing to go during this disease. Okay. And as we get older. And what we've found is that you can grow new neurons in the hippocampus from structured exercise and consistent exercise. The biggest growth is going to occur because of BDNF, brain-derived neurotropic factor. So this is a growth factor for the brain, and it gets released when we exercise. It gets released abundantly when we are doing aerobic training, when we're running, when we're cycling for long distances, but it also gets released when we do resistance training. Now, here's the beautiful thing about it. When we do resistance training and we're releasing all of these myokines are signaling molecules. They work together. So we've got one called irisin. Okay. And that's a messenger molecule. So what it does is it actually helps BDNF express itself. So when we release this myokine, it goes into the brain, crosses the blood-brain barrier, and it tells BDNF to express itself. So then BDNF goes in and it helps grow new neurons in the hippocampus. But then we've got another myokine. Let's just take IL-6, interleukin 6. It comes from the interleukin family.
What is that? Sorry.
The interleukin family is a class of pro-inflammatory cytokines. So these get released when we are under stress or you've got an infection or a virus, for example. But when we exercise, it depends on where the site is. Interleukin 6, instead of acting as a pro-inflammatory cytokine, instead of creating inflammation, it acts as an anti-inflammatory cytokine. So it goes into the brain and it lowers inflammation. In fact, this was one of the first ever myokines to be studied, and they showed that interleukin 6 is also responsible for the downregulation of tumor cell growth. So exercise is a potent anti-cancer intervention as well by way of myokines.
How much exercise does one need to do to avoid the cancer-related side effects, but also the Alzheimer's problem?
Well, just 30 minutes a day of aerobic physical activity can downregulate 13 types of cancers. And the most prominent ones being breast cancer, colon cancer, and prostate cancer. So these three have been studied most, and you get your anti-cancer effects from the myokine release. So quite specifically, when we exercise, we're getting a robust release of something called natural killer cells. And when we get these natural killer cells into the plasma and into the bloodstream, they go into the tumor site and they do what they were born to do. They kill. So they go into the tumor site and they start to kill the tumor. And this is where you get your anti-cancer effects of it. But you can also get it from the anti-inflammatory effects of resistance training, anti-inflammatory effects of aerobic training. So these myokines are really powerful. In fact, pharmaceuticals are spending billions of dollars trying to replicate these myokines in a bottle, and they can't do it. I want both men and women lifting heavy because you've got areas in your brain right across here lives your motor cortex. Think of your brain as real estate. There's real estate in your brain reserved for lifting heavy. So every time you lift a heavy weight as opposed to a light weight, it takes more neural real estate to lift that heavy weight. So the heavier you lift, the greater the neural drive. The greater the neural drive, the better it is for your brain.
If you had to do just one exercise for the rest of your life to protect your brain, and you could only pick one, what would it be?
Deadlift.
Why?
If done correctly, the deadlift can use almost every muscle in your body, erector spinae. You've got the glutes, you've got the quads, you've even got serratus anterior, you've got your calf muscles. There is so much compounding in that one lift. Would probably be comparable to a barbell squat as well.
According to the World Health Organization, we're getting increasingly more sedentary. We're moving less and less, in part because of technology, but also there was this really interesting study done by the Cleveland Clinic where they talk about people who are active sedentary. And this felt a little bit personal, if I'm honest. It says a major finding in 2025 found a danger of being active sedentary, which is people who exercise for like 30 to 60 minutes, but sit for the remaining 10 hours a day. If you sit for more than 10 hours a day, your risk of cardiovascular disease increases even if you meet weekly exercise goals, because prolonged sitting shuts down lipoprotein lipase, an enzyme essential for burning fat and cleaning glucose from the blood. That's annoying to read because I feel like that's me.
Yeah, and being sedentary is a disease. You can change the trajectory of your life by doing 10 air squats every hour on the hour. And there was a study that was done on this that showed that if you do 10 air squats every hour. This can compensate for your sedentary lifestyle because unfortunately, this is the life we're living in. We are becoming more sedentary in our day-to-day lives. We're sitting more. We're not going out as much. There's younger kids on video games. They're scrolling. There's so much happening that is involving our sedentary lifestyle, which is obviously, like you said, increasing our risk of type 2 diabetes, cardiovascular disease, etc. Yep, you can do it.
Like this.
There you go. 10 of those. If you do 10 of those, you can outweigh the benefits of a 30-minute power walk.
Every hour?
Yeah.
For how many hours?
8.
Okay. So I could set an alarm on my phone.
Every hour. Just get up, or every 45 minutes get up and do an air squat. And this is primarily because have you heard that when you eat, you get a massive spike of glucose? And the best way to bring that glucose spike back down is by doing any form of exercise. You can albeit go out and go for a fast run, do an air squat, bring that glucose level back to baseline.
And do you think much about aerobic training as a preventative measure for Alzheimer's?
I love aerobic training. Women are facing a dilemma on social media because they're being given so much information. There is this huge uproar of should I do zone 2 exercise or should I not do zone 2 exercise?
What is zone 2 exercise?
So we can think of physiology in zones. Zone 1 is what you and I are in right now, right? Zone 2 is that next level up. And that's generally when we're looking at exercising at around 60% of our maximum heart rate. And it's where you're jogging, but you can have a conversation, but where you're huffing and puffing. When we're exercising, we need to produce energy. And that energy firstly starts in the mitochondria. So we need, all of our energy gets created. We create ATP, and that's how we are able to perform the given task. As soon as we get out of that zone and we go into zone 3, zone 4, and zone 5, we're producing energy outside of the mitochondria in the cytoplasm. And when we're doing that, in order to do that, we're breaking down glucose so fast via a pathway called glycolysis. The byproduct of that is lactate. And then we produce lactate. And that's actually a fuel source for the brain. It's also a myokine, right? So that's when we're in zone 3, zone 4, zone 5. So a lot of women have been doing zone 2. They've been going to the gym. They've been doing zone 2. And I'm trying to push women to get out of zone 2 for several reasons. Not because it's not good for you. I think all forms of exercise are good for you. The more you move, the better, right? But let's be really honest. A lot of people in midlife are busy. They're time poor. Men actually get a greater return on investment by doing zone 2. Women don't get the same return on investment from doing zone 2. So I'm trying to push women to first work on zone 5, zone 3, zone 4, zone 5. If they can, just do zone 5. Then do 2 to 3 sessions of resistance training a week. And if you have time left over, that's right there. I've just described around 4 hours of exercise. If you have time left over, then you can work in zone 2. Now, zone 2 is great. If you're going to go out and go for a long run, you're doing many things. You are secreting a lot of BDNF, which we need. It's a growth factor for the brain. You're getting a massive amount of blood that's going into the brain, which is great as well. It's sustained. Blood delivers oxygen and nutrients to the brain. You're doing a lot of things, right? But what you're not doing is having a complete effect on the chambers of your heart.
Is it better for me to do 5 kilometers on a treadmill or outside?
I would say it's better for you, for the brain, to do a smaller amount of exercise and a higher threshold.
Because I think I read somewhere one time that running outside is better for the brain because it stimulates the brain.
Of course, well, you're outside, so you've got so many things around you. Imagine your brain, I told you, it's got prime real estate. Every part of the brain is responsible for a different function. From what you see to what you hear, you go outside and you can see so many things. You've got forward ambulation, so that's going to help you with drive, motivation, dopamine, but then you're also taking in the sounds, the senses. It down regulates inflammation. So you get so many other things from doing that. Yes. But 5 kilometers outside compared to 20 minutes of high aerobic physical activity. What is better for the brain? I would say that the zone 5 is better for the brain. The zone 5 training does a lot for the chambers of your heart as well. Now, I'm going to grab this. We've got a little model here. And we can see that we have a left chamber, we have a right chamber, we have actually 4 chambers of the heart, but we have something in the heart called a ventricle. We've got a left ventricle and we've got a right ventricle. Now, the left ventricle delivers oxygenated blood to the entire body. It's really interesting because the chamber of the left ventricle is like a muscle, right? Mm-hmm. It's responsible for pumping blood to your entire body. It first gives blood to the brain, which means it's the most important part of your body. After it's done giving blood to the brain, it goes through to the rest of the body. As we get older, we get stiffening of these arteries, okay? Stiffening of all of the arteries in the heart, and we get something called left ventricular hypertrophy. So that's when the left ventricle, it starts to get thicker. And when it gets thicker, that means that it's not as strong, it can't pump a lot of blood as much as it could when it was younger to the rest of the body. Dr. Ben Levine, he's a sports cardiologist, and he did this landmark study which changed how I thought about zone 5 training. He took a group of sedentary males, average age, I think it was around 47 to 55, so around 50 years old, and he scanned their hearts. He did echocardiograms, he took photos of the heart, he did everything he could to see when I was first starting the protocol, what does their heart look like? He then subjected them to around 4 hours of exercise per week. And that was stratified against, he did 1 resistance training session a week. 1 was high intensity physical activity at around 90% of the maximum heart rate, the VO2 max heart rate. And then in between, he did some long sessions as well, right? But it was all moderate to rigorous exercise. And that was done over 2 years. At the end of those 2 years, what he found was that he remodeled the heart by 20 years. So he reversed the age-related effects and defects of the heart by 20 years, essentially turning the 50-year-old hearts into 30-year-old hearts, just from physical activity alone.
4 hours a week for 2 years?
4 hours a week for 2 years.
And what kind of exercise was it?
So he got them to do, like, let's say, for example, one of the protocols was exercising at 90% of your maximum heart rate. So when we do this, we're generally looking at increasing our VO2 max. So you've probably heard that VO2 max, along with strength, but VO2 max is the strongest predictor of all-cause mortality, right? So if you want to improve your VO2 max, and if you want to get the heart-related changes that he did, what you want to do is you want to do 20 minutes of VO2 max per week just to keep your VO2 max, because it does decline year on and year out. Starting at the age of around 35, we start to see a decline in VO2 max. So if we want to work on our VO2 max, we want to be doing what we call the Norwegian 4x4. It's the gold standard of increasing your VO2 max. So you want to get your heart rate elevated to 90 to 95% for 4 minutes on, 4 minutes off, repeat 4 times. So how do I do this? Well, I actually do this twice a week, because the more you do, the better. I do this on a stepper. I do this at the gym, and I put my stepper onto, I think I'm at like level 14, and I'm working my way up, and I'm staying on there for 4 minutes. And then I'm having a complete stop and a complete rest for 4 minutes. And I'm repeating that 4 times. Mm-hmm. So what I'm doing in that moment, I'm not just getting a massive shunting of blood to the brain, okay, which is good. I'm not just getting a massive release of myokines and exokines to the brain. I'm also remodeling the heart. I'm downregulating tumor cell growth. I'm improving my cognitive performance. I'm doing so much more than just exercising alone.
So that's once a week in Levine's study that reversed these guys' hearts by 20 years.
Yeah.
That you do that once a week?
You only have to do that once a week. But he also did, he did around 70% of maximum heart rate for around 2 hours a week. And he also threw in 1 resistance training session. So consistency is key.
I'm just looking at some of the findings of that study, and one of the surprising things is it showed that there is a biological exploration date per se for the reversal of the heart.
Yeah.
And then the heart retains its plasticity, the ability to remodel itself, until the age of 65. If this intervention had started after the age of 65, the heart was too stiff to be physically remodeled to get to that 20-year reversal.
Yeah.
You have to start in late middle age.
Exactly. So midlife is the window of opportunity for brain health and for longevity.
I didn't realize you could sort of remodel the heart yourself. That's interesting.
Yeah, you can remodel the heart. And the heart is amazing, okay? Because what you see with the aorta, right? So the aorta goes up, and we've got the main blood supply for the brain exists in the vertebral arteries. Okay. So there's branching off of the aorta, comes from the heart, vertebral arteries, which supply the posterior part of the brain and the cerebellum with blood. And then you've got the carotid arteries. So one on each side, branching off the aorta, which supply the frontal and middle part of your brain with blood. The brain is the most vascular rich organ in the entire body. In times of stress, such as hypertension, okay, that is elevated blood pressure, we see that we can actually kill off the tiniest parts of the blood vessels, which are called the capillaries. You can see the capillaries up here. They supply even the blood-brain barrier. So they supply mainly the outer cortex of the brain with blood. When we have elevated blood pressure, we are starting to kill off those tiny little capillaries of the brain. Those capillaries are feeding different neurons in the brain and also feeding the blood-brain barrier. So when we get breaking off of these, we lose the blood supply, we lose the oxygenation, we get a breakdown of the blood-brain barrier itself, which is scary. And we see that in patients who have got mild cognitive impairment. You can call it, you've heard of leaky gut, we can call it leaky brain. If you have a leaky brain, what happens eventually is, so your blood-brain barrier sits like this. Okay. And there are cells, and we call them pericytes, for example, and they're bound together by tight junctions. That's what the blood-brain barrier is. It's like you think of the blood-brain barrier as the bouncer of a nightclub. They are all standing there like this, responsible for who can come in and who can't. And they don't allow some molecules to get in. But over time, when this starts to degrade and become leaky, they start to spread apart. And when they do, you can have the passive diffusion of all these molecules coming in, and that's really bad for your brain. So we want to maintain the integrity of the blood-brain barrier by maintaining the capillary health. We don't want the capillaries to die. They're one cell thick. Any type of damage can damage them and kill them. Hypertension. There was a really great study. It was actually the SPRINT trial, and it's now the gold standard for the recommendation of 120/80.
What's that?
So when you have your blood pressure taken, we get the systolic over diastolic. And I don't know if you take your blood pressure, but doing your blood pressure every day is a really great, inexpensive and effective tool for maintaining good brain health. So you measure your blood pressure, and if you are hypertensive, this is anywhere over 135. Okay, systolic over 135. That's when things start to break down. That's when we start to get the breakdown of those small one-cell thick capillaries. So in this trial, in the SPRINT trial, what they found was that when they aggressively manage these patients and they bring their blood pressure down, they did it pharmacologically through something called an ACE inhibitor. It's a medication to drive down blood pressure. When they bring it down pharmacologically, these patients preserved their brain, gray matter, and their cognitive functions. So we now have a gold standard. And this is what I would recommend anybody. On Amazon, it costs about $25 for an automatic blood pressure monitor. Do it every single morning and watch your blood pressure.
And then if it's high, what do I do about it?
Well, outside of pharmacology, if we don't want to take a medication, we want to get stronger, and we want to do this via exercise. Stress is one of the biggest things driving high blood pressure. manage stress, manage cortisol, manage chronic inflammation by way of exercise, sleep, all of the things that Mother Nature gave us.
I was just looking at the study that reversed the heart by 20 years and trying to figure out what exercises they did. And as you said, the first one was the high intensity workout, the 4x4.
Yep.
Then they did a long aerobic exercise. Again, this is all once a week. So 60 minutes once a week doing a longer exercise, like it could be hiking or tennis or cycling. A moderate intensity workout, 30 minutes, where they did the talk test. You should be able to break a sweat but still be able to speak. So that was once a week. And then lastly, strength training once a week. So it's really a variety of exercises that caused such a profound impact on the heart. And I think cardiovascular diseases are the single biggest killer.
Yeah. Cardiovascular disease. Dementia is the number one killer of women in the UK. They're number one.
Really?
It's the number one cause of death in Australia for both men and women.
How does it kill you? Because we all think about memory loss and stuff like that. But
yeah. And so this is the actual devastating part. We don't die of Alzheimer's disease specifically. Over time, what happens is in these patients, you have to remember Alzheimer's disease is like end-stage cancer. Once you get the diagnosis, there is no cure. There is no going back. There is no reversal. You have the disease, and that's the scariest part. Mild cognitive impairment, you can slow the progression of that. Like I said to you, it goes for 20 years, mild cognitive impairment. You can slow the progression of mild cognitive impairment, but as soon as you get diagnosed on that awful day that your mother or your friend gets diagnosed with Alzheimer's disease, it's a sad day. And what ends up happening with these patients is you can die of asphyxiation. You can die of your brain loses the signal to swallow. It loses the signal to maybe you fall because you've lost balance. It's a really scary moment, but it's not like you die of Alzheimer's disease specifically.
if you were diagnosed with Alzheimer's disease, it's an interesting reaction.
Because I would have no hope. I think a better question is...
You'd have no hope?
If I was diagnosed with Alzheimer's disease, there is nothing I could do.
How would that change your life and the decisions you make? Or would it at all?
I would aggressively exercise. I would monitor my diet. And I would potentially have a ketogenic diet, because what we've found is that during this metabolic crisis that happens in your brain, okay, where you lose the ability to use glucose as your primary fuel source. So the brain doesn't know how to use glucose as its primary fuel source, so it's under attack.
During Alzheimer's? During
Alzheimer's, but also during this window for women as well in the perimenopause state. So the brain cell, when it's under attack and it can't utilize glucose effectively and it doesn't have any energy, it starts to think about survival. It starts to think, what can I do? I'm under attack. So it starts to break down the myelin sheath. And in that moment, it's actually the astrocytes. They're the supporters of the brain. So of the brain cells. So they start to think, okay, let's break down the myelin sheath. From that, the astrocytes produce ketone bodies. And then the ketone bodies get shuttled into the brain. And that's how we use energy in the brain. So in that state of metabolic crisis, I would make sure that I am having a ketone-rich diet, or I may be getting exogenous ketones. I would aggressively exercise. I would aggressively manage my lipids. I'd have a high intake of omega-3 fatty acids, and I would preserve, if I could, any form of cognitive function by way of talking to people, by going outside, socializing, having hard conversations. If I was intact and I could do so, I would throw tennis balls to the wall.
So on that point of the ketogenic diet, the reason is because ketones are an alternative fuel source to glucose.
Yep.
And the brain likes ketones.
The brain loves ketones and it actually utilizes them more effectively than glucose, but glucose is the primary fuel source for the brain. And here's what's really interesting and devastating, if you will, for females. During the onset of perimenopause, right? When we see a decline in estrogen, right? We see a decline in estrogen. What happens is a 30% reduction in brain glucose metabolism. So when these receptors start to die because we don't have a lot of estrogen circulating in the bloodstream anymore, what happens? Well, we can't utilize glucose as effectively. So during that state, that's when we start to get the breakdown of the myelin sheath to use that as ketone bodies as an alternative brain fuel source.
So do you think women going through menopause should be considering a ketogenic diet?
Yes, I do think that. I think that women who are going through perimenopause and who are at the mercy of this brain energetic crisis should be adopting, if they can, a ketogenic diet. It's one of the best diets for the brain.
I didn't really understand this idea that during menopause there was a glucose deficiency or metabolism problem in the brain?
30% reduction in brain glucose metabolism.
Is this why women report having brain fog and all these kinds of things?
Yeah, absolutely. Because when the brain can't utilize its fuel source effectively, what happens? Well, metabolites start to shift. We don't sleep properly. Around 60 to 65% of women in menopause report having a hot flash or night sweats. It wakes them up at night. That's also causing cognitive decline and brain fog.
So, I mean, this graph's pretty shocking. Can you explain what it shows?
Oh, this is showing the estrogen levels at birth, going through all of the life cycles that a woman will go through: puberty, perimenopause, and then eventually menopause. There is one thing that is certain. After age, I mentioned earlier, being a woman is the next strongest risk factor for getting this disease.
For getting Alzheimer's. And that largely lies in our menopausal shift that occurs, the downsizing of estrogen. However, we do have forms of estrogen that we can, supplement with. So I just need to keep the estrogen up.
Yep.
Because then the brain health is going to be up and normal.
This is where the controversy lies. Yes and no. So I want everyone to understand, I am sitting right now. So my entire doctoral thesis is focused on women and Alzheimer's disease. And I'm Switzerland right now when it comes to hormone replacement therapy. That is replacing your hormones.
You're Switzerland.
I'm Switzerland, meaning that there is no evidence to suggest right now, we don't have large scale randomized control trials to show that hormone replacement therapy prevents dementia. So what I will tell you is this: it is a signal. It is a supporter. It will help you do the things that can lower your risk of dementia. We've seen multiple times that having hormone replacement therapy can reduce your risk of getting Alzheimer's disease by up to 30%. We know that. But it's not because estrogen alone is minimizing your risk. It's because when you have estrogen, it helps get rid of the hot flashes. It helps with the night sweats, because during menopause, when we actually have a dysregulation of estrogen in our brain, what happens in the hypothalamus, which is an area in the brain that controls our temperature regulation. When we lose the ability to monitor our temperature for a woman, what will happen is when she feels the slightest bit hot, her temperature is rising a little bit. The hypothalamus doesn't know what to do. So it signals, I'm super hot. So it'll raise your temperature right up, and that's a hot flash, and then it'll bring it right down. And as a result, this is keeping women up at night. And we know that sleep deprivation is a risk factor for Alzheimer's disease. Of course it is. Compounding sleep deprivation will accumulate amyloid beta in your brain. So if we can use hormone replacement therapy as a signal and as a support to help us sleep at night, then that's a good thing. Another thing, estrogen is anabolic to muscle.
What does that mean?
It means that it helps with muscle protein synthesis.
Oh, it helps me make muscle.
Yeah, we've got estrogen receptors on our bone. We've got estrogen receptors on our muscle. So if estrogen is anabolic to muscle, if estrogen helps with muscle protein synthesis, if estrogen helps with bone mineral density, then replacing estrogen during that menopause state is going to help us with all of the risk factors of Alzheimer's disease.
So when does estrogen, I mean, it really, in this image, drops off a cliff.
And it varies. So it tends to generally happen at around 45 years old as an average, and that perimenopause stage lasts around 10 years.
But it starts going down on this graph at about 30.
It starts to go down, and everyone's different, okay? You can have a woman in her late 30s go into perimenopause, or the general age is around 42 to 45. Most OBGYNs that I've spoken to say that you need to start checking in with your doctor at around 40 years old to check for this.
So do you think, thinking about my fiance now, do you think that someone like her should go on hormone replacement therapy at like 40?
Well, so that's the big question. That's the elephant in the room. Should you go on hormone replacement therapy or should you not? And that's definitely a conversation between you and your physician. However, we've got large scale studies right now to show that we don't have to be afraid of hormone replacement therapy. And without going too deep into the weeds, there was a massive study that was done, the Women's Health Initiative, that scared women out of taking hormone replacement therapy in fear of getting breast cancer. Yeah. Correct. We went from having 40% of women on hormone replacement therapy to just 4% of women on hormone replacement therapy. Wow. We know that even at the onset of menopause, a woman's risk of having a heart-related event triples. A woman's risk of getting Alzheimer's disease increases. So there is something to posit here about the benefits of hormone replacement therapy that we still haven't yet studied.
Will you do hormone replacement therapy?
I definitely will.
And what kind of hormone?
And look, so this is really interesting. So this was given to me by a friend, and this is the capsules. So this is estradiol and progesterone. Okay. So progesterone is that one that's going to help you sleep at night. This one here is vaginal estrogen. So this is a cream that actually gets, depending on how it is, it can get inserted. And the vaginal estrogen, apparently, if you put it on your face, is probably the best form of skincare that you could ever have. Yeah, we have estrogen receptors all over our tissues, including our skin. These are estradiol inserts, so that's not the cream itself. But if you get vaginal estrogen in the form of a cream, you can put it on your face and it can help with skin elasticity, collagen, dermal thickness. This is why I'm actually most excited about it.
So, I mean, are these the only ways that one can do hormone?
No, there's also a patch, and that's what most women are opting in for.
What will you do?
The transdermal patch.
When the time comes?
I will probably do the patch.
Why?
Because it's the easiest. That's the one that I've researched the most. I'm not afraid of hormone replacement therapy in the slightest. You do have to, everyone has to check with their doctor, but I definitely think that this is going to be one thing that is going to help with the Alzheimer's disease crisis that is occurring.
Go ahead.
I mentioned earlier plaques, right? So a lot of people ask, well, what distinguishes Alzheimer's disease from the rest of the dementias? And it comes down to two proteins, amyloid beta and tau protein. And here's where it gets really interesting and actually dates back to 1901, the first ever Alzheimer's disease patient, Augusta DT. She was 52 years old and she went to the hospital. Her and her husband went, complaining of difficulties of word finding, word fluency, and she couldn't remember where she put her keys. And her husband said she is delirious. And Augusta told the doctor on board, he was a psychiatrist, his name was Alois Alzheimer. She said to him, and I quote, "I don't know who I am anymore." As I mentioned, this disease robs you of who you are. In 1906, Augusta DT died. And that was the first ever patient to be recorded of having Alzheimer's disease. And so post-mortem, they cut her brain open and they found that she had these plaques in her brain, and they didn't really understand what it was, but that was the first ever induction of this disease in society. And ever since then, we are still trying to tackle this disease. In the 2000s, we had this notion that Alzheimer's disease was the amyloid cascade hypothesis, meaning that, great, Alzheimer's disease means when you get a head full of amyloid, this toxic protein that builds up. So we were demonizing this protein. We were demonizing this peptide protein that builds up in the head. And so then came the medications, okay, in the form of IV drugs. So you go to the hospital, you get an IV in the promise that it will clear out amyloid. Great, we've got a cure. But what they found was that when they were taking out the amyloid in these brains, they were taking with them brain tissue and causing microhemorrhages. And in some patients, it was resulting in death. So we now know that the problem here isn't amyloid. In fact, amyloid is a antimicrobial peptide. So amyloid is actually a good thing. Amyloid beta is a good thing because it protects the brain cells. Now, here's what happens. We have this beautiful process during sleep that occurs. When we get into deep sleep, we activate the glymphatic system. Okay, so the glymphatic system comes from the word glial cells. We have glial cells in the brain. They sit outside of the neurons, and this is what is responsible for immunity. They're a chief immune response cell. During deep sleep, they shrink. And when they shrink, all of this amyloid beta that's floating around in the cerebral spinal fluid gets washed out. So it's like a washing machine that occurs in your brain, right? But what tends to happen in Alzheimer's patients is they don't get a chance to wash out the amyloid. What happens in perimenopause and menopause due to the hot flashes, you don't get to get into deep sleep because you're having a fragmented sleep because you're waking up due to hot flashes and night sweats. So that is what's causing the buildup of amyloid. Now stick with me. We've got another protein that is a hallmark of Alzheimer's disease. It's tau protein, and tau lives in the axon of the cell, the one that I said is covered in the myelin sheath. And what happens under times of stress? What happens is this tau protein phosphorylates. So it breaks off, and basically tau protein stabilizes the microtubules. Okay, imagine these railroad tracks in the axon. Okay, just going up and down the axon.
The axon's in the cell or in the brain?
So the brain cell itself, the neuron, is the neuron cell body, and the axon is like the trunk of the tree.
Okay.
Right?
Yep.
So holding up the tree are microtubules, and those microtubules are bound by tau proteins. The tau proteins keep the microtubules intact, so the trunk of the tree is stabilized and it sits there. Why does it need to be stabilized? Because that's how speed of thought travels. Information processing speed travels up there. When the tau protein phosphorylates, it starts to form tangles. They're called neurofibrillary tangles. So that happens in the axon. And when all these tangles clump together, we get the collapse of this axon, the collapse of these microtubules. So we're not just having a cascade of environmental disaster inside the cerebral spinal fluid of the brain and inside the brain, outside the cells. We've also got this cascade happening inside the cell body itself. So the brain is under attack inside the cell and outside the cell.
Why?
Why exactly? Why? Why does this happen? Because of how we treat our brains.
Because of how we treat our brains?
Yes. The reason why your brain is hyperphosphorylated and the reason why these tau proteins are hyperphosphorylated is because of many things. One is we have seen time and time again that we have estrogen receptors that are in the brain cell themselves, in the axon. So when we don't have adequate estrogen actually is so smart. What it is doing, it's blocking an enzyme that is responsible for phosphorylating the tau. So if we don't have the estrogen there, then the enzyme is there to phosphorylate the tau. and break it down and cause these neurofibrillary tangles. But let's just say you're a man and you don't need the estrogen there, although testosterone is neuroprotective. Testosterone actually aromatizes into estrogen, which is why you actually have an extra added protection in your life. What else causes this? Well,
sleep?
Stress.
You were talking about sleep there.
Yeah. So sleep is, I think, by far the most underrated Alzheimer's disease prevention tool that we have. It's underrated because we have been doing it all our lives and we think that we can just go to sleep and the magic happens. But I think now in 2026, we actually need to train for sleep. So during deep sleep, we activate the glymphatic system, and sadly, a large proportion of us aren't getting into deep sleep. So sleep is one of the reasons.
How do you sleep?
Yeah, I sleep. I make sure I sleep 7.5 hours a night.
This message is brought to you by Apple Card. It's a great time to apply for an Apple Card. You'll love earning unlimited daily cash on every purchase. That includes 3% daily cash when you buy the latest iPhone, AirPods, or Apple Watch from Apple. Through this special referral offer, when you get a new Apple Card, you can earn bonus daily cash. To qualify, you must apply at apple.co/getdailycash. Apple Card issued by Goldman Sachs Banks USA, Salt Lake City branch. Offer may not be available elsewhere. Terms and limitations apply. All I had to do was brain dump. Imagine if you had someone with you at all times that could take the ideas you have in your head, synthesize them with AI to make them sound better and more grammatically correct, and write them down for you. This is exactly what Whisperflow is in my life. It is this thought partner that helps me explain what I want to say, and it now means that on the go, when I'm alone in my office, when I'm out and about, I can respond to emails and Slack messages and WhatsApps and everything across all of my devices just by speaking. I love this tool. And I started talking about this on my behind the scenes channel a couple of months back. And then the founder reached out to me and said, we're seeing a lot of people come to our tool because of you. So we'd love to be a sponsor. We'd love you to be an investor in the company. And so I signed up for both of those offers. And I'm now an investor and a huge partner in a company called Whisperflow. You have to check it out. Whisperflow is 4 times faster than typing. So if you want to give it a try, head over to whisperflow.ai/DOAC to get started for free. And you can find that link to Whisperflow in the description below. A lot of people struggle with sleep and they've just kind of gotten used to it. I hear this from friends of mine that will say, I'm a bad sleeper, I'll sleep for 5 hours, and they kind of have just gotten used to it. Do you think that's okay?
No. And they will pay for this in their 60s and 70s.
How do you know?
Because I know that just one night of sleep deprivation is raising your risk of amyloid beta by at least 4 to 5%. And
just one night?
Just one night. So you can imagine the accumulation of this. Not only that, we know that you're interrupting with the hormones that are responsible for hunger and satiety. We know that you're increasing your risk of type 2 diabetes with sleep deprivation. But not just that. We also see that this compound effect can't be reversed, meaning that a lot of people think I'll just sleep for 6 hours a night and then just bank on it on the weekend. But sadly, that's not how our brain works. It's not like debt that we can repay to the bank.
I heard from Matthew Walker the other day, though, that we can save it up. He said you can't make up for lost sleep.
Exactly.
But if on Monday I've got something where I know I'm going to be deprived, he says on the weekends, like Saturday and Sunday, if I got a huge amount of sleep, it's kind of like I can use that.
Yeah, it's kind of like the reserve. Yeah. Actually, I do this. I do long haul flights, albeit like 6 hours between LA and New York, but also to Australia. And so if I know I'm going on a long haul flight, I'll bank on my sleep for about a week leading up to that, because I know I'm going to be sleep deprived on the plane. So
if you were one of those people that struggles with sleep that's listening right now, and they're slightly concerned that, you talked about this glymphatic system, which sort of comes out at night and cleans up the brain, and they're hearing, shit, my glymphatic system isn't going to be optimal if I'm not sleeping. If that was you, and for whatever reason, you start sleeping poorly, what would you do about it?
I would get really serious about examining my lifestyle the day before. So this generally involves 2 things. You have to ask yourself, are you having trouble falling asleep or are you having trouble staying asleep? A lot of women report trouble falling asleep, meaning they've got a racing mind. Men too. They've got this racing mind. They can't, just stop that default mode network and the racing thoughts that happen. That's one thing. And then there's I can't stay asleep, meaning that I'm waking up due to heat. I'm waking up because I'm stressed and I'm having bad dreams. There's all different reasons as to why you wake up. So for the person who is having trouble falling asleep at night, I would strongly recommend introducing a supplement called GABA, which is gamma aminobutyric acid. It's our chief inhibitory neurotransmitter. And when you have this, it really helps stabilize all those thoughts. It helps with a racing mind, and it can help calm you down at night. The next thing I'll do is I will think about what I'm eating. Actually, it turns out that eating starchy vegetables, something that's going to make you, sweet potatoes, for example, it's going to have a better benefit, backloading your carbs at night for helping you sleep. If you start training for sleep as if sleep is your marathon and start preparing for that at 8 p.m. at night, getting off, don't email, don't have any hard conversations, don't watch anything crazy at night, you'll settle your mind down, you'll settle your nervous system down. But where I think most of the optimization occurs is when you're actually in sleep. I would also work on sleep regulation. So what we know is that in order to fall asleep and stay asleep, our core body temperature needs to drop at least 2 degrees. And I'm doing this with a temperature-controlled mattress because it's working on thermal regulation. A lot of people who don't have that can do several things like sleeping with their feet outside of the sheets, or turning the air conditioning on, the thermostat on, to cooling the room, to cooling down your body temperature, core body temperature. One thing that you can supplement with is glycine, which I think is amazing because it helps with sleep by way of temperature regulation. It can bring down your core body temperature. And in fact, and I don't know too much about the mechanism behind this, glycine itself has one of the greatest longevity benefits for improving lifespan. So taking glycine can also help with that. Now, in terms of the person who is having trouble staying asleep.
What about this one? You didn't talk about the old Ashwagandha.
Oh, yeah. Ashwagandha is great. Okay. Ashwagandha is going to help you with stress. And you've got here Ashwagandha Rhodiola. So what they both are, they are adaptogens. And basically an adaptogen is great because it goes in and it adapts to what is happening in your body. So let's just say you have elevated cortisol. And this tends to happen, during different cycles during the day, mainly during the daytime when we wake up, where cortisol levels are at its peak. But it can also happen at night. Having this can actually stabilize that cortisol because it can go in, it can bind to cortisol and bring it down. Likely, if something is not elevated and it's low, it can bring it up. So it's really good. It's an adaptogen, and studies show that you can actually take this 3 times a day and you won't feel fatigued. It doesn't disrupt anything, and it pairs really well with caffeine, for example. So does theanine. So this is actually a really great adjunct to your supplement stack.
And you really talk about how you need to sort of warm up to warm down, or warm up to go to sleep.
Oh, yeah.
Starting at 7 p.m.
Yeah, starting at 8 p.m. And that's in line with circadian rhythm and circadian biology. You want to try and, when it comes to sleep and your circadian rhythm, you kind of want to mimic the sun and Mother Nature. And when does the sun start to go down? It starts to go down at around 8 p.m., depending on where you are in the world. And when this happens, we also get the natural release of, I love that you're taking that, by the way. You must be stressed right now. You get the natural release of melatonin. So melatonin is that sleepy hormone that gets released in response to darkness. This may also be another reason why somebody is having trouble falling asleep and staying asleep. So we want to get the natural release of that. So these biohacks that occur right now, sleeping with our red light mask on, dimming the lights. Look, dimming the lights is great. I've actually replaced all of my light bulbs at home in my bedroom as well with red light bulbs. So I'm getting rid of the blue light, the junk light. I'm replacing it with red light to help down-regulate the nervous system. Yes, I do wear blue light blocking goggles, or glasses, I should say. Do I think that they're providing an immediate and huge benefit? I don't know, but they could have a minor benefit there. So warming down involves doing these things that are going to help you down-regulate your nervous system so you can fall asleep faster.
Sticking on supplements for a second, omega-3.
Yes.
I've got some omega-3 here. I've got 2 of them here. Mm-hmm. But when I brought both of them out, you said that I've got to be quite careful about what brand I buy, but also something about temperature.
So by far, out of all of the supplements, omega-3 is probably the only one that you have to make sure that you look at the supplement label for. There was this study that was done that showed that around 95% of the most popular omega-3 supplements in the US, and there was about 85 of them that were tested, exceeded the normal oxidation level, meaning that these pills, because they're omega-3 fatty acids, they come from fish oil, they are oil, they can become rancid and oxidized. And they usually do this when they're in a heated environment. Here are the rules of thumbs. One, you want to look for a manufacturer that is highly credible and that is certified.
Certified?
Yeah. So NSF certified. So it's an external governing board that certifies them on, everything, heavy metals. They make sure that the oxidation levels are met, and they make sure that, what's in the capsule is actually in the capsule. That's another thing that is scary. The supplement industry is highly unregulated. And I treat my omega-3s the same way I treat my olive oil. You want to get oil that is sourced in the area that you are. We're in California right now, so you might want to find an omega-3 that is sourced in California.
Do I want to put it in the fridge?
You want to put it in the fridge the moment that you get it.
Really?
Yeah.
Why does nobody talk about that?
I'm not sure, but it's just the same as olive oil. You don't want the olive oil to become rancid, so you don't leave it near the stove. You want to put it in a cupboard away from the stove.
And these are good for the brain?
Omega-3s by far one of the most potent stimulus that you could have for the brain. They help with cell membrane fluidity. So where your cells meet, neuron to neuron, they create something called a synapse. And in order for that to occur, we have a massive influx of all of these neurotransmitters. Dopamine, serotonin, we've also got calcium and potassium, and these help our brain cells communicate, okay? We want to make sure that our membranes, the cell membranes, are fluid and they glide in order to help with that synaptic transmission. Another thing that they do is they are comparable to an NSAID, an anti-inflammatory medication. These have massive anti-inflammatory effects. In fact, I think that these have the safety profile of an FDA-approved drug, and there's only benefits from it. There's no side effects from it. Not just that, 60% of our brain is made of fat. 70% of that is made of DHA. And DHA comes from omega-3 fatty acids. So why do I not want to replace my brain or the fat in my brain with what it's made of? And that's what you do when you have omega-3 fatty acids. In fact, there's been several trials to show that omega-3 fatty acids are most beneficial and most effective for mild cognitive impairment patients, people who have the ApoE4 gene, and people who have got Alzheimer's disease. Because when I told you that we get the breakdown of the blood-brain barrier, those parasites on the blood-brain barrier require DHA. In fact, there's a transporter on the outside of our brain that allows the DHA to come in and get into the brain.
And I know you're a big fan of vitamin D as well, because there's been some very encouraging studies done there.
Vitamin D is phenomenal. We have vitamin D receptors all over our brainstem, and they're abundantly found in the hippocampus and the memory centers of our brain. And there was actually a study done on centenarians in China.
Centenarians?
Those who lived to 100, but it was done in women. And they showed that the women who preserved their cognitive functions and who didn't get Alzheimer's disease had high levels of vitamin D. So they weren't vitamin D deficient. In fact, being vitamin D deficient can increase your risk of all-cause dementia by 40%. Likely, having a high level of vitamin D, which is around 60 nanograms per deciliter, can lower your risk of getting Alzheimer's disease by around 80%.
And then we have this white powder in front of me. You've got a big smile on your face.
I do, because there is just so much benefit to this, depending on which brand you've bought, of course. But I can't say enough about creatine. I have my parents on creatine. They're 71 years old. I've got my dad on high-dose creatine. I've got my mother on low-dose creatine. It's the most widely studied supplement on the market.
I've never seen you this excited.
I'm so excited because I think that this is a really cheap and effective way to get everything you want from both your physiology, an upgrade on your physiology, and your neurophysiology. So let's actually talk about creatine, because I know it gets a lot of airtime, but women and men are still scared of it. And they're scared of it for two reasons. One, they're scared it's going to cause kidney damage. And two, they're scared their hair is going to fall out. And I'm going to address both of those fears. But first, let's talk about what it is. So creatine is a naturally occurring molecule. We produce around 2 to 3 grams of creatine per day. It gets secreted from a bit from the brain, but a lot from the liver. And 2 to 3 grams a day is great, but it's not enough. So we have to supplement with it. And all through the 90s and all through the 2000s, people were supplementing with 5 grams a day. That is this scoop here, 5 grams of creatine per day. Now that we're getting more rigorous with our brain health studies, we have found that creatine has enormous benefits for the brain. But here's the problem. When you have 5 grams of creatine, you're saturating the muscles. Okay, remember, the muscles are so hungry, so they get first dibs and they take up all of that creatine. So then there's none left for the brain. We also lose a bit of the bioavailability when the creatine goes into the brain. It crosses the blood-brain barrier, but when it goes into the brain, we lose some of it. So we have to supplement with more than 5 grams. And one of the studies that changed my thinking came out last year. It was the first ever pilot study done on Alzheimer's disease patients. You're talking about patients whose brains are under attack. They're in an energetic crisis. They cannot produce energy effectively. ATP is all skewed. Brain glucose metabolism is skewed. They don't remember left from right. Cognitive functions are declined. They put them on 20 grams of creatine per day.
Which is how much? Show me.
Actually, that is 4 of this. So you want to go 1. And I don't know if they did this all at once, that's 2, or if they did it like me over 4 separate intervals throughout the day. There we go.
That's a lot of creatine.
That's a lot, which is why you probably want to have this skewed throughout the day, which is what I did. I had 20 grams today. I had 5 grams in the morning, 5 mid-morning, and then I think I had 10 all at once before I got here. So that is a lot for all at once. And what they found was that these patients not only preserved their cognitive functions, but they had more energy and they were able to exercise more. And it blew my mind that it does not matter how old you are. It doesn't discriminate based on gender. Creatine doesn't discriminate based on age. It doesn't discriminate based on weight. It doesn't discriminate based on pathology or disease states or ethnicity. It is just there. It is there to support you. It's the most widely studied supplement on the market.
What is it
doing? And it's all risk. It's all reward. There is no risk. It's helping with cell energy metabolism. So basically it's helping ATP create energy.
So if you're someone that is low energy, you should definitely be having creatine.
I don't care who you are, you should definitely be having creatine.
People with brain fog and...
Yeah, people with brain fog. You know, I think one of the greatest benefits are men who are in football players. It's actually a protective molecule. So what studies has shown is that at high doses of creatine, around 30 grams a day, it can protect you against insults. Insults meaning you take a hit to the head, like a concussion. It can protect your brain against a concussion. It can protect your brain against a stroke. It can protect your brain from stress. The best thing about creatine is that it works in the background of stress. I think that's where you'll get most of the benefits from.
After hearing so much about creatine on this podcast, I started recommending it to all of the people in my life. There's one particular person actually that's probably out there in my house at the moment who had gone through cancer treatments.
Yeah.
And had survived cancer treatments and, in their words, wasn't the same on the other side of the cancer treatments. And I talked to her about creatine, and she said to me the other day, I think the exact quote was, "I feel like I've got my life back." Because she's been taking creatine every single day for the last, I'd say 5 months or so.
It's funny you said that, because just recently in the last 2 weeks, this study was done to show the anti-cancer effects of creatine. And if my memory serves clear, they dosed it at 0.36 grams per kilogram of body weight. So if you are a 70 kilo person, if my mathematics is correct, you're looking at around 25 grams of creatine per day that can have the effects, the anti-cancer effects.
So the study you're referring to, I'll put up on the screen as well for anyone that wants to see it. It's the NANS 2025 study, which was a major study involving over 25,000 adults, found a linear negative association between dietary creatine and cancer prevalence. For every standard deviation increase in dietary creatine intake, the risk of having cancer decreased by roughly 5% to 18%, depending on the demographic.
That is wild.
This protective association was strongest in adults over the age of 50, suggesting that as we age, maintaining higher creatine levels might be more critical for cellular health and immune surveillance.
Well, if you think about life and think about energy, we need energy to survive. We need energy to fight off infections. We need energy to fight off stress, preserve our normal bodily functions. So when we are at the mercy of a low energy crisis, we can't fight off tumor cells. We can't fight off these debilitating diseases. So it actually makes sense that with more energy and with more functional energy, meaning that if our cells can function better, it makes sense that you can see a reduction in cancer incidence. Likely, you can see a reduction in Alzheimer's disease incidence. When I said that creatine works in the background of stress, also there's been phenomenal research to show that you can basically creatine your way out of sleep deprivation. So if you've had a long night and you're sleep deprived, maybe you slept 4, 5, 6 hours, you're sleep deprived, you can take high dose creatine in the form of around 15 to 20 grams a day, and you can reverse the negative effects associated with that sleep deprivation.
Does it matter what time you take the creatine?
It doesn't matter what time you take the creatine. It doesn't degrade in hot water. You can take it anytime throughout the day. And it doesn't matter whether you're taking it right before exercise, during exercise, after exercise. It works phenomenally. Some people, researchers are now wondering if taking it at night before bed helps with sleep performance. And I think that that's a really exciting area. But the one thing that I want to tell everybody, because a lot of people are scared of this biomarker called creatinine, meaning that
my doctor said that to me.
Yeah. So meaning that you've got a high creatinine level. And this is a marker it's one marker of kidney function, but this is where I find it really invaluable. And this is where a lot of the nonsense comes around on Instagram and social media. A lot of people say, well, I had so much creatine that my doctor told me to get off it because my creatinine levels were high. But creatinine levels are high during times of stress, during times of intense physical activity, and also people who have a lot of muscle mass. That's higher right. Muscle mass, that's you, have higher creatinine levels. What you want to test, a greater marker of kidney function and GFR, is cystatin C. So all you have to ask, it's really easy, ask your doctor, could I please get cystatin C in my blood work? And if that is elevated and not within normal range, then maybe get off creatine. But right now, I cannot see any reason as to not have creatine every single day. I think every single person, no matter what age you are, everybody should be supplementing with creatine. Now, there was this recent study that came out on menopausal women, and it was a really small study. It was a randomized control trial, and they split women into 4 groups, and these were perimenopausal women. They split them into low-dose creatine, where I think they were having 750 milligrams a day, medium dose, which was around 1.5 grams a day. Then they had them supplement with a range of both creatine monohydrate and creatine hydrochloride. This was a hydrochloride creatine study. And then there was a placebo group. What they found was a very small study, very small group. What they found was that those in the medium range, having the 1.5, had substantial increases in their mood and their cognitive functions. So creatine is now being explored in females across the lifespan as it relates to perimenopause, pregnancy, menopause, and dementia. So it's phenomenal. The only thing I want to point out, what you want to look for when it comes to creatine are 2 things when it comes to manufacturing standards. You want to look, A, has it been NSF certified? And B, you want to look for, is it CreaPure? And that's the gold standard of creatine. And it comes from Germany. And so the one that you've got there, I can tell it's not CreaPure.
Excuse me.
I know my creatine.
How can you tell what it is by looking at it?
I can just tell. I bet you $1 million that it is the brand that I think it is, because it's got this powdered icing sugar substance. If it was pure gold standard CreaPure, it would be gritty. The reason why it's like this is because a lot of manufacturers want to add these different agents in there in order for it to mix well. This probably mixes really well. A lot of people also complain of feeling GI distress when they take it. And all I have to say is that's not a reason to stop taking it. Maybe take 2 grams at a time, maybe take 3 grams at a time, but don't stop taking it.
What do you test for with your own health, and how frequently do you test?
I test every 3 to 4 months.
What do you test?
Oh, I do everything.
Really?
I just did lab work December 15th, the day before my birthday. I do it, around that age. But every year, funnily enough, I test my biological age.
What is your biological age?
It came back as 22.
Fucking hell. What's the most important test they don't typically do that you think everybody should be doing?
Lipoprotein (a) raises your risk of having a heart-related event or raises your risk of getting cardiovascular disease, but it's hereditary.
And then for dementia?
This is a really exciting part, at least in the US. We now have a predictable way of picking up on mild cognitive impairment and picking up on these Alzheimer's hallmarks. Tau protein, p-tau217 it's called on blood work, and amyloid beta. So we can now pick up on this with 90% accuracy of a PET scan.
What are those cards over there?
These are here to test your processing speed.
Pink.
So
it says pink on it.
Yeah. So this is actually a great measure of brain function. Your brain processes visual information 15 times faster than written words. And so this is going to test your brain function. Okay. So what I want you to do is you're going to see the color.
Yeah.
I want you to actually say the color of the card, not the word.
Okay, let me just program my brain. Say the color, not the word.
Yeah.
Okay.
Are you ready?
Green, orange, yellow, green, orange, green, orange, yellow, pink, orange, green.
Now let's do the reverse. I want you to say the words.
Oh, wait, let me just... Okay. Yellow, blue, green, black, purple, brown.
Okay, so you're good.
Thank you. Let's do it to Jack. Jack, you come sit in the chair. It's your turn.
You caught him off guard, and he hasn't got creatine. That's unfair. It's an unfair advantage. Okay, you ready?
Wait, so what am I doing?
Just say the color of the card.
Okay, just the colour of the card.
Yeah,
okay.
Ready?
Green, orange, pink, yellow, yeah, orange, pink.
Now, let's roles reverse. I want you to say what's on the card itself. So just read it.
Okay, brown, purple, pink, green, black, yellow.
Okay. So now we're going to test it even more. That was the starting rate.
Good. Not too bad.
That was not too bad. So I want you, this actually involves us standing up and using a tennis ball. So we're going to train your visual cortex, which sits at the back here in the occipital lobe. We're going to train your processing speed, your reaction time, your hand-eye coordinations. One of the best exercises that you can do, physical exercises, is actually hand-eye coordination drills. Tennis, racket sports, but I'm going to show you what 5 minutes a day can do for your cognitive reserve and your brain performance, just using a tennis ball and an eye patch.
Okay.
So, first things first, I'm going to give you this tennis ball.
Yeah.
And for the whole time, I want you to throw the ball with an overhand grip.
Oh, like this?
Yep.
Okay.
So I want you to just throw it with the right arm and catch with the right arm.
Over. I mean, what's this one
That's
saying?
underarm.
I'm just checking the wall. Okay. Okay. So like.
So you might want to move back where the chair is. Okay. No, you're good.
Cut that. Cut that out.
Good. So now throw with the right and catch with the left and alternate. Yep.
Okay.
You've got it. So what we're doing, we're engaging almost all the executive functions now. You've got hand. You should be able to do this for a minute. Okay.
Okay.
Now we're going to make it even harder. It's like placing weights.
Go on, you do
on
it as well.
Well, I'm not going to do the one with the eye patch. I'll do the next one. Okay. So basically what you want to do, and if you do it with a black ball, it's actually, even better. So now we're going to make it a bit hard and a bit neurally demanding. We're going to put an eye patch on you, which is really going to block out like 50% of the vision.
Okay. Which eye?
Any eye.
Let's do the left one.
Let's see how many you can do. I think we counted around 8 before.
A pirate.
I just get you to look at.
What? Oh, wait, this is not flattering. Okay,
Let's
cool.
go.
Oh, that's so different.
Yeah,
Wow. This feels significantly harder.
I know. Let's go.
This feels like really hard. Let me just double check. Fucking hell.
Wow.
That's so hard. This is...
There you go. You've got it.
Joking. No.
Okay, let's alternate now. Left hand,
Easier.
right hand.
Left hand, right hand. Like this.
Yeah. You're training your visual system to work under load and under stress. So when you do this, I'm interrupting you.
No, it's okay.
You got it. Good. And then to even make it even harder, okay, stand on your right foot
Yeah.
and put your other foot. There you go.
What, on one leg?
Yep. Standing on one leg is now engaging the cerebellum.
Okay.
We're getting spatial awareness. Let's go. Posture.
Left, right?
Yep.
Oh my gosh.
You got it.
I want to see you do it.
With the eye patch on.
Yeah.
Wow. I mean, I can bet. Great, my eyelashes have gone now.
It's okay. We can AI that out.
This actually looks great. Okay, we're ready? Well, I blame my nails. Let's do it. Okay.
It's hard.
It's so hard.
And so what is this doing?
This is engaging executive functions, processing speed, hand-eye coordination.
And you did this with NBA players?
I did this with NBA players to improve their executive functions, decrease their reaction time.
And this will change my brain if I do this frequently.
Not just that, but you're also improving cognitive reserve. You're building new connections between the brain cells. You're strengthening neural networks, and you're doing something incredible.
You know, every once in a while you come across a product that has such a huge impact on your life that you'd probably describe it as a game changer. And I would say for about 35 to 40% of my team, they would currently describe this product that I have in front of me called Ketone IQ, which you can get at ketone.com, as a game changer. But the reason I became a co-owner of this company and the reason why they now are a sponsor of this podcast is because one day when I came to work, there was a box of this stuff sat on my desk. I had no idea what it was. Lily in my team says that this company have been in touch. So I went upstairs, tried it, and quite frankly, the rest is history. In terms of my focus, my energy levels, how I feel, how I work, how productive I am, game changer. So if you want to give it a try, visit ketone.com/Stephen for 30% off. You'll also get a free gift with your second shipment. And now you can find Ketone IQ at Target stores across the United States, where your first shot is completely free of charge. If there's anything we need, it is connection, especially in the world we're living in today. And that is exactly why we created these conversation cards. Because on this show, when I sit here with my guests and have those deep, intimate conversations, this remarkable thing happens time and time again. We feel deeply connected to each other. At the end of every episode, the guest I'm interviewing leaves a question for the next guest. And we've turned them into these conversation cards. And we've added these twist cards to make your conversations even more interesting. And there are so many more twists along the way with the conversation cards. This is the brand new edition. And for the first time ever, I've added to the pack this gold card, which is an exclusive question from me. But I'm only putting the gold cards in the first run of conversation cards. So get yours now before the limited edition gold cards are all gone. Head to the link in the description below.
So doing hard things is what is going to improve brain function over the lifespan. Doing hard things tells your brain that you can do hard things. Meaning, have you ever heard of this brain area, a little area in the brain called the anterior mid-cingulate cortex?
Yes, I have.
What do you know about it?
I'll let you say it.
Well, it's shown that it's larger in what we call super agers and people who age really well and who can withhold a lot of cognitive capacity. And it's really profound in people who can diet well. It gets bigger when we do hard things. So when we do really hard things, this area in the brain gets bigger. And basically what that is, it's reserved for when life gets hard. It basically tells your brain that no matter what happens, no matter what event comes my way, I have the ability to go in, welcome it, and push through it no matter how hard it's going to be. When you give up or when you don't do hard things, this little area doesn't grow. It doesn't get bigger. So doing these neural activating drills that we just did, going to the gym and pushing well above your threshold and pushing really hard is going to help grow this little area of the brain.
And they call this the willpower muscle.
The willpower. This is why I think that when people go out to set their goals during the year and they say, I'm going to lose 20 pounds, I'm going to do this, I'm just going to increase my willpower, I think it's not willpower, it's neurobiology.
I think it's really important to just spend a little bit of a moment talking about this part of the brain, because when I discovered it, I found it absolutely fascinating. And I think it was Andrew Huberman who said, either to me or he said publicly that he thinks it's one of the most fascinating or important discoveries of the last century.
Of course. Well, you think about how we're living our lives. We're punishing ourselves for not being able to read a book, for not being able to pay attention. How many, people are now self-diagnosing themselves with ADHD, low attention spans. And they're blaming it on environment. They're blaming it on circumstances when they should be blaming it on neurobiology, and they should be blaming it on their brain state. This area of the brain, if you can push, and this is why these superages seem to have...
What's a superager?
A superager is somebody who is aging well. So they're going through life, low cardiovascular disease state. They've maintained their cognitive functions. They're at the age of 80, 90 with a VO2 max profile of maybe a 50 or 60-year-old. So they're aging quite well biologically. So these, superages have many, many different facets to them. And one of them is a larger mid-cingulate cortex.
Conversely, the AMCC, anterior mid-cingulate cortex, shrinks in people who live sedentary lives or avoid challenges. It literally atrophies if you play it safe in life too often. Growth only occurs during resistance. If you love taking ice baths and you take one, your AMCC doesn't change. If you hate the cold but force yourself to do it anyway, the AMCC grows. Scientists now view the AMCC as the seat of the will to live. Its size and activity level are strong predictors of how long an individual will survive after a major setback in their life, whether it's a health setback or a surgery.
There's something really philosophical about that as well. I don't know if you read Stoicism or anything, but it really dates back to how the Stoics lived their life, especially Marcus Aurelius, with being able to push through hard times. Little did they know that it was this little area in the brain.
Yeah, I think I was telling the story the other day of Roosevelt and what happened in his life as a young man when he came home one day on Valentine's Day and found that his mother and his wife, who had just had his newborn baby, had both died, one upstairs, one downstairs. And he went off to the Badlands for 2 to 4 years. The Badlands in America were just this horrific natural place where he'd get up at 4 a.m., ride these horses in the freezing cold where the horses would literally die standing still because it was so horrific. He did that to 2 years to deal with the grief. But when he came back to New York City after the 2 years in the Badlands, all of his friends said he was just a completely different man. And what they now know from a neuroscience perspective is that he didn't just build his muscles. He literally rewired his brain. He went on to become the youngest US president of all time. He got shot during a speech and carried on doing the speech. He led the charge in various wars. He's just this unbelievable person. I think he won the Nobel Prize. And they point at those 2 years in the Badlands and say, actually, that forged not just the man, but his brain, his AMCC. The studies also show that athletes consistently show much larger AMCC volume. And studies show that individuals struggling with obesity often have smaller AMCCs, but it begins to grow the moment they start a successful, challenging dietary or exercise intervention.
It's that word challenging, because when you place stimulus upon a system, it adapts and grows. And that is neurobiology at its most infinite source. And this is why we get the breakdown of these synapses. This is why we get into a place of going from 5,000 to 10,000 connections to 2,000 or no connections. These dendritic spines end up breaking down because we don't do the hard thing. And I also think, being deep rooted in neurobiology, you can see that everything is cause and effect, and it's a cycle. If you don't do the hard thing, you don't grow the AMCC. You don't grow the AMCC, you don't do the hard thing again. And it's just this loop and it's this cycle, which is why so many resolutions, New Year's resolutions, end by February 1st. It's why we have the obesity epidemic. It's largely why I think we've got a crisis of people not being able to meet their goals.
I'm just fascinated from an evolutionary perspective as to why we needed one and why it wasn't just always big.
In the pursuit, evolutionarily, in the pursuit of hunting and going out and hunting for food sources and being motivated to do that in a near starvation state when times were tough.
And so when times got easier, we didn't need it as much, so we could conserve, I guess, our energy, so we could scale down our willpower when times were good.
Well, it's interesting that you say that, because this brings up the whole brain rot and AI era. Just like with, in 2024, Oxford Dictionary, I think, named brain rot the word of the year. And it's interesting because it plays into evolution and what's happening with this AMCC, meaning like we're just there scrolling at mindless information every day, training our brain to get these small dopamine hits, these small rewards from doing absolutely nothing.
What do you think of these chatbots that everybody's using at the moment to write for them and think for them, etc.?
Oh my God, I think it's on the spectrum of being so incredible, but being so detrimentally harmful. I know this with myself. So I was a mathematician. I did my master's of mathematics, and I was able, Stephen, to the trigonometry and pure calculus that I could do back then with just my head and a pen was fascinating. Now I'm going out and I'm calculating on ChatGPT the bill, the 20% tip on top of this bill. How much does it cost? And I think, how dumb am I actually getting? So I think it's both good and bad. I think the rate of decline we're seeing in people reading books and exercising their brain is declining, and our ability to think and use our cognition is declining.
Louisa, I've waited a long time to ask you one particular question, which is, I think is very important, which is you're clearly very passionate about this stuff. One might say you're pretty obsessed with it. You come across as pretty obsessed.
Do I?
You do, yeah. Why?
We are living in a society that doesn't allow women to ask for what they want. We're living in a society that doesn't allow women to ask for what they need. And when this happens, it results in 70% of all Alzheimer's disease cases being women. It results in 80% of all autoimmune diseases being female. And these are largely preventable diseases. And when I ask why, and I hear that women are wildly misrepresented in academic literature, when I see women who downplay their symptoms, or they're too scared to ask their doctor for advice, or they're too scared to ask somebody else for advice because of what they're going through, or they're ashamed of some of their symptoms, I get angry and I get passionate. And it reminds me of my grandmother who, she was my best friend. Her name was Louisa. And
you're named after her?
I was named after her, yes. And we spent every day together. And I'm getting emotional now because I remember her. And she sadly died of pancreatic cancer. It was ovarian cancer that went to pancreatic cancer. And she never asked for what she wanted, and she never asked for what she needed, which was help. She didn't understand her symptoms. She didn't go to the doctor when she needed to, because she was just more inclined to look after the family and look after the household. And when the time came that she was given her diagnosis, I was sitting there with her. It was at home, and the doctor came. She did a house call, and my grandmother looked at her. She hardly spoke that much English, and she said, "Please, is there something I can do? I don't want to die." And the doctor said, "I'm sorry, there's nothing you can do." And I spent every day with her in the hospital. And I think about that. It's been almost 20 years now, but I think about that moment and I kick myself thinking, why didn't we get her a scan? She told us several times that her stomach was hurting. She told us several times that she felt pain. She hid her symptoms. She hardly ever ate at one point, and we never stopped to think about why, and she never stopped to think about why. So I think about her every day. And then I think about my mother too. And these women, first generation, they came, we migrated to Australia from a country called Cyprus, and they've just been they put themselves second, and they just look after the family. And I can't stand that. And when I see women coming in as patients or caregivers, I think to myself, do you not know that there is something for you to do? And most women don't. And I can't believe the amount of money that we are spending that is going towards putting us on rockets to go to Mars, but we haven't yet found a cure for this disease that is largely preventable. It's just not okay with me. And I would hate to see women go through this.
The emotion is still very present in your face, even though it was so long ago.
It was so long ago. I mean, I was very close to her. I'm very close with my mother. I check in with her twice, 3 times a day. And I just don't think it's fair. I think women deserve the truth. They've been lied to. They've been underrepresented. And we need to change that.
With Louisa, your grandmother, what are those range of emotions that have turned into this incredible fire you have?
Anger. Anger is one of the emotions. Anger at society that places women to be everything, to be a mother, a caregiver, to go to work, to represent the family. Women represent 51% of the total population. And then it becomes, I feel, political, if that's an emotion, because you think about healthcare. You think healthcare should be accessible to everybody, but it seems as though, especially in this country, that healthcare is only really accessible by those with a high socioeconomic status. And that I'm not okay with. So it does become political, even though I guess healthcare is political because policies have been set, but a woman in need is apolitical. And my grandmother was apolitical. And her needs just were not met.
Anger.
Frustration at the system, frustration at the fact that we still have only 4% of women taking hormone replacement therapy in fear that they're going to get this disease, that they're going to get breast cancer. Utterly frustrated at the cycles of administration who vouch to help you. You look to your government and your administration to look up to guide you when you have Secretary Kennedy in 2014 go on national television and say, vaccines are totally safe. I had all my kids vaccinated. They've eradicated some of the most deadliest diseases that have plagued this world. Vaccines are so safe. To fast forward to 2025, saying vaccines are so unsafe. Do not trust your medical doctor. You need to take your health into your own hands. You start to lose trust. And it's not that we're uninformed. It's the fact that we are confused because we hear vaccines are bad. Oh, vaccines are good. Vaccines are really good. Take them. Don't get your kid vaccine. You've got women here who don't even know they don't even know how to get on the internet or order a blood testing. You're expecting them to take their health into their own hands. So it upsets me that you see women who are so vulnerable being sold a vaccine lie, which could potentially save them from a disease, which could potentially save them or their child from getting the flu, hepatitis B, meningitis, which was just eradicated from the vaccine schedule. This is not meant to be political. I'm a scientist. This is not propaganda. This is not ideology. This is just women who deserve to be treated better.
You're 36. Louisa passed away when you were how old?
Oh, I was probably 18 at the time.
You were 18?
Around that, 18, 19.
When she got the diagnosis?
Yeah. It was very fast. It was within a 2-month time frame, not even.
And had she not got that diagnosis, and had you not sat there and watched her ask that doctor if there's something that she could do you think your career would have taken this course?
I became utterly obsessed with disease management, but when I first saw a human brain, I was 21. I was in a lab and we had to go into a cadaver lab, and I saw a brain being harvested from a body that was donated. And I stayed back that day, I remember. And I helped in the pathology lab. And when I saw that brain, I knew that I wanted to dedicate my life to it. So ever since then, I've been in ORs, and it's where I feel most alive.
Why? Why did you want to dedicate your life to it?
Because when you know what the brain is, that it is responsible for the life that we have, and you can use it for your advantage to overcome any obstacle that comes your way, you become obsessed with understanding it. Metacognition is thinking about your thoughts. And every day, if you can think about why you think, about the things you think about, you can challenge yourself to overcome any adversity.
Is there a cost to your obsession and your passion?
Yes.
What's the cost?
I moved away from my family to be surrounded by the greatest neurosurgeons in the world, which I am. And I'm very thankful for that. I moved away from a population of 22 million to come to the hardest city in the world. New York City.
Are you still paying a cost?
I'm still paying a cost. My health pays a cost. I've missed family events, traveling for my career. But I wouldn't have it any other way, because the people that I've met have forged the way for me to live the life that I want. I'm surrounded by incredible thought leaders in health and medicine. And
so what is success to you then? At the deepest possible level, what is success? We meet again in 10 years' time, you say, my life has been a success, or I feel successful. Louisa says, I am a successful woman. What does that mean? What happened?
Being able to control my brain states.
Being able to control your brain states.
I think that the ultimate form of success and high performance, or being able to perform at your peak, is being able to go from brain state to brain state and then be able to recover.
What do you mean by brain state?
Meaning like being
Tiredness.
able to get switched on when you need to be switched on and invite the neurotransmitters involved in that, norepinephrine, adrenaline, dopamine, but not having that in constant overdrive and being able to know when to switch off. And I think that that is what high performance is. The book that changed my mind on that was Flow by Mihai Csikszentmihalyi, which actually speaks about the flow state. So being able to know how to separate yourself in these states.
Any goals outside of your professional goals?
Kids, family, life.
You have kids, family?
Yeah, definitely.
It's tough, isn't it? It's tough. I was saying earlier to my friend that, kind of just thought the minute I wanted to have kids, they would just appear. But it's not so straightforward.
That's what I thought too, until I realized, but I'm the woman. I actually have to bear the children as well.
Which is a big sacrifice. And an honor and a privilege.
It's an honor and a privilege and a sacrifice that I think everybody, I think I definitely want.
Are you hopeful for all of your professional endeavors?
Yes.
You are hopeful?
I'm in control.
You think we're going to move in a good direction as a society as it relates to Alzheimer's and...
Yes, I'm hopeful for that. I'm hopeful for the message that I'm getting across. I think social media is providing the platform for free education and for people to understand that they have agency over their brains. I'm not hopeful for anybody saving us or coming in and giving us a easy way forward.
Do you ever have days where you wish you were less obsessed with your craft? Has there ever been a day where you're like, I wish I was just a little bit less captivated by this?
Sometimes I do, yeah. I think if I didn't, I'd be probably back home in Australia living an average person's life. I'm not saying that that's it. I'm just saying, maybe I would have done my life differently.
I have days like that where I think, obviously, because the obsessed brain is the one making this decision, so it's quite difficult to detach. But like if you put a knob in front of me and I could just turn it down just a little bit, would I? Now, my obsessed brain is the one making this decision. So my obsessed brain's not like, fuck it, turn it up. But I think, I do wonder sometimes, I am the way that I am, right? But I do wonder sometimes if I would be happier overall if I could just turn it down a little bit.
But isn't the whole point of life to know thyself and in pursuit of something bigger and better?
Yeah, it is. But I just sometimes worry about what I'm sacrificing and whether at some point, I don't know, when I'm on my deathbed at 80 years old, I'm going to look back and say, actually, I made a bad trade.
Well, exactly. But we're never going to know that. I think about
Someday
that often. I know. You think about that often and you think, well, if the world came to a collapse tomorrow, what would you regret today not having done?
I think it would be like making more memories with people I love. I think that's one of the big ones. I think...
Did you hear what you just said?
Yeah.
Making more memories. And imagine losing those. Imagine a life full of
unthinkable.
Creating these experiences and these memories to have them being taken away from you.
Yeah.
To not being able to recognize your wife, your kids, and looking in the mirror and not being able to recognize yourself.
That's why Alzheimer's is just such a disgusting, sinister, horrific thing. Because, it's the most heartbreaking thing to lose someone while they're still alive.
Yeah, and to lose yourself. We've got this one woman who looks in the mirror and she says, "Who's that?"
Really?
Yeah, and it's sad because 2 years ago she knew who I was, and now she asks, "Are you my daughter?" And when you're confronted with that every single day, it gets you thinking. You don't live a normal life. You don't live an average life because you do think about every facet of medicine. You think about history, you think about diseases, and then you think about life and the people that you spend the most time with.
We have a closing tradition where the last guest leaves the question for the next, not knowing who they're leaving it for. And the question left for you is, what is God to you?
God is that power that you feel and have faith in that you cannot see. The power that basically makes you feel like there is somebody there that has you and that is guiding you. That always has a path for you. Knowing
you believe in God?
Yes, I'm Christian. I'm Greek Orthodox.
When you see the brain deteriorating in such a way, and you think about this concept of prayer, like asking God to help me with something, doesn't it feel pretty... it's the definition of hopelessness, is watching your brain deteriorate. And I think some part of my struggles with religion since I was an 18-year-old and I came from a very religious family was seeing injustice in the world. And there doesn't seem to be much greater injustice than watching someone's brain just deteriorate in front of their family.
Yeah, or somebody going through losing their child and you start to think about God.
People pray for, I can't find my keys, or I want my football team to win. And I go, there's no point. If people praying for an Alzheimer's cure are having no luck, then maybe I should stop praying for Manchester United to win.
Yeah. If you understood the intricacies of how we were actually brought into this world, from the point of conception to the point of neural development, how a baby is formed and how precise everything has to be for you to come out the way you did. It is so beautiful and so miraculous and so rare, even though there are billions of people in this world, that you can not just turn to biology anymore. You have to turn to something bigger. And I used to, trust me, even as a Christian who's read the Bible, even in my early 20s when I was getting into medicine and science, I was so gung-ho about we're born in a body, we die in a body. But then when you get so deep into the literature of science and medicine and biology, it's hard to ignore God. And it's hard to ignore that there is a higher power out there. And why is it that there are chapels in hospitals?
Because people want to go to heaven?
Because people want an alternative method of getting through whatever it is that they can get through, something that science and medicine cannot offer. And believing in something that is not there or something that hasn't occurred yet is having faith. Mm-hmm. I work in neurosurgery, and some of the cases you think this person's not coming out of here alive. And the fact that they do and they preserve their cognitive functions and they look next to normal after they've had a massive tumor resected, which is a true story from here. The tumor was going all along this one woman's face who was 78 years old, who traveled here from France to have the tumor resected. How is it that she's walking and she's cognitively normal and she's not even on any medication the next day? How is that possible? Is it God? Is it just miraculous neurosurgeons? There's just some things that medicine can't answer.
I agree with that. I don't think I'm arrogant enough to say that I know. And I'm curious, and I think I'll never know.
Yeah.
So I guess that's where we need to have faith.
Yep.
Louisa, thank you so much. It's very important that you do the work that you do because it's people like yourself that are so passionate and so obsessed and so good at communicating that help average people who don't have access to the wisdom and the research and the studies and information that you have understand all of these things. And it's through this understanding that we can make better choices and preserve our life, preserve our brains. And if we preserve our brains, we preserve everything that matters.
Correct. Thank you.
So thank you for doing what you do. And I appreciate your passion and dedication to it because it's very, very important.
Thank
and
you
I know it comes at a cost. So I feel obliged to tell you that as a normal person who isn't involved in your field, we're grateful.
Thank you so much, Stephen.
Thank you.